We
Hi
are ready.
everyone. Hi everyone. Today we are going to explain about the function, applicative functors, and monoids. We are from the University of Bosque, and we are from with the teacher Pedro Guillermo Fijo Garcia, and the students are Álvaro Antonio Stark Ramirez and Mauricio Corral Martinez, and the last one, Victor and Esperanza Leon. This expose a PowerPoint contains the module in relation of this topic. Okay, the first thing or the first topic are what are monads? Okay, monads are structures that let you connect a structure, pass them, or even structure them in a sequence. As you can see in the picture, this is the sequence contains the first input. The first monad contains the type A, and in the content we can watch a function, and the return is the monad B. Okay, they add a context of possible failure to values, and we can see that as applicative functions. Um, Monads less structured procedures with sequence operation. Okay, and different from the functional programming paradigm to kind of see them as structural steps. In in relation of these three objectives or the declaration of the monads, the picture get the reason of these monads in relation of the function, the contains types, and the return types. This sequence contains different variables, and these variables made different things. Monads can be used to manage exceptions, to reassign variables, to control input and or output operation, and in situation with concurrence context. These are because we can have and flow and control flow in our monads. For example, if we have a function that have two inputs in relation of two variables, we can have sections in this function. And for this reason, we need to make an exception and catch these exceptions to did affect the output result or the return type. And for example, if we have variables, we can make different things, not only manage exceptions. If we have to reassign the input and make a simple operation, we can do this thing with the function. We can change, for example, the input A to the A plus 1, and we have a lot of possibilities to control this input and or output. It's and or because we can only change the state of the variable, and the output maybe is only for not only for reference but not for the result. um, the concurrence context is a really nice feature that contains the monads, because the concurrence is, for example, execute different flows at the same time. And if we have a lot of variables of input, or we have different inputs, we need to uh, make these things or operation in less time. For this reason, the context of concurrence is a really nice solution. And going back to the image, the types are important because, for example, the M represents the monad, and the A is the input type 1, is the first input. And as you can see, we have the function that is in relation of A. But in relation of A, we have to manage the monad B, and that return the monad B. But we can have a function inside monad B. For example, this function may return or may do something to change the value of B. It's a really simple example, but this sequence um, can we can have the opportunity to be really creative in this structure because we have a lot of um, ideas or we have a lot of operations in in relation of that, and we can see the applicative function in relation of the monad. For example, this expression, we can have we can define the variable. For example, we have different operations. We have the management of these characters, and we that makes a function that takes a number and gives that the number. In relation of different operation and together they add the results. Mm, relation of monads, this is the different functions that we can have inside the B operation. And this is a really nice example to use that. And okay, continue, Victor.
Okay, so if we going or if we will go to see some practice or some examples of these monads, we have three. We have three, for example, rules or uh, parts of points that we can see as examples. So, for example, not only is the function type a functor, an applicative functor, but it's also a monad, and the function can also be considered as a value with a context. Okay, for example, when we instant monad and we have a constraint that return a part or a operation, we have a functor or applicative of that functor that can be also a monad. Second, it takes a value and puts it in a minimal context that always has that value as its result. So we always have a result that can be a monad of a value. For example, when Daniel explains us the what is the structure of a monad, we can see that the result always is a monad. Okay, and third, the sequence we use that operation that symbols with the equals to fit a monadic value to a function. The result is always a monadic value. Okay, so in this case, when we fit a function to another function, the result is a function as well. This is, for example, if we go to program languages like JavaScript, when we use high order components in React, or when we use graphs that we can use functions inside functions. Okay, so if we go next, the state of a monad is really important to understand, that we can see the structure or we can see how implicitly this works. So the state monad wraps computations in the concept of reading and modifying a global state object. Okay, this context chain two operations together in an intuitive way. First, it determines what the state should be after the first operation. Then it resolves the second operation with a new state. That is, for example, when Daniel showed us this particular feature, that is the recursion, because this grab and grab and grab function, and this will be progressively or recursive progressing or process that function that are grabbed. Okay, so in this example, for example, we have the syntax of how can we get a state monad with a practice example. Okay, when we go next, this is really important. Okay, we could have a data type with exactly the same functionality as, for example, a Java class. Okay, we will just have many functions that can modify the global state of the class object using the state monad. So this is important when we need to build or to create a program that is not only some specific functions, that is some like an object that it can be some features or some operations by itself and behaving like an object. So with this feature of Haskell, we can do that. Okay, and for the last, as summary, we have these three important points. Okay, a state in one or more variables that are required to perform some computation but are not among the arguments of the relevant function. Okay, the state type is designed to simplify, okay, to simplify this process of threading a state through the functions in Haskell. Okay, second, monads can be used to do various things such as reassigning variables or EO operation. Okay, and the state monad grabs computation in the context of reading and modify a global state object. Okay, so this is 3 points that we need to have in mind when we will use monads in our Haskell programs. Okay, so that's it. Okay, bye bye.